Okay, class, here is the review for the atomic theory test that I gave you the other day, and I hope that this helps you out. Okay, the first question says, Boyle's law at constant temperature, the pressure and volume of a gas are related in what way? Well, there's an inverse relationship between pressure and volume, meaning that if pressure goes up, that means the volume went down. If you decrease the volume, then the pressure will go down. There's also a mathematical equation that you can use that we touched on just a little bit, but don't worry too much about this. I don't want you to get too wrapped up in that. So let's move on to the next question. We see the problem that we crossed out here had to do with using this equation, and we're not going to go over that, so don't worry about it. Okay. Here is the next one. I'll call this number 2. It says if two gases at the same temperature and pressure have their pressures doubled, what is the relationship between the two volumes? Well, basically, if the pressure is doubled, that means that the volume is going to be cut in half. Okay, so you double the pressure, then you do the reciprocal of that, and you get half the volume. All right. Okay, question number 3 says, what theory do we use to explain the pressure volume behavior of gases, and what does that tell? Does that theory tell us about the existence of atoms and molecules? And it gives you a hint that KMT stands for kinetic molecular theory. Those were in the Boyle's law slides. Basically, it says that gases are made up of small particles called molecules. They are quite invisible and in constant, rapid, random motion, never slowing down as long as the temperature stays the same. They collide with the walls of the container, imparting force and thus showing a pressure. Here's those slides. If you want to take a look at them again, they're in Google Classroom, and they were posted in for you about a week and a half ago. Also remember that that's the one that proved that there was the same amount of molecules in a given volume. They just had different masses. That's why I put the same amount of molecules in these little examples here, but ones are bigger than the others because of their masses. Okay, question number 4 says, do molecules in a gas move slowly or quickly? Are the molecules close together or far apart? Well, they are fast moving and they are far apart. That is true for all gases, especially if you change the temperature and pressure on them. Okay, question number 5 says, law of combining volumes. When two gases react together and start off at the same temperature and pressure, how do the volumes of the reactants relate to each other? Well, that's from that old video that we watched that one day with the combining gases, and it tells us that they combine in small whole numbers and or integers, just like you said on that video from 1989. Okay, next question, number 6. What is Avogadro's hypothesis? Basically, equal amounts of particles in a certain amount of volume. So it doesn't matter what you're looking at, a compound or an element. If it's a gas, the equal amount of particles will equal the same in that amount of volume. Okay, question number 7. It says, what is the law of conservation of mass and how does it support atomic theory? Well, mass is neither created nor destroyed; it is just rearranged, and it supports atomic theory when you show where the mass goes in the chemical equations. You have to account for the mass on the left side of the equation, and it should equal the mass on the right side of the equation. Okay, for question number 8. It says if 4 grams of a substance A react with exactly 20 grams of substance B to form substance C, how many grams of substance C are formed? Well, that goes into this and leads into this. So if you have 20 plus 4 grams in the reactants, then you have 24 grams in the product. So here's your reactants, and you draw that arrow there, and here's your products. Basically, you have mass that's conserved because you have 24 on this side and you have 24 on that. All right, question number 9 says, what is the law of constant or definite composition? Basically, is you can find the percent of a compound by dividing that part by the whole compound. So we did that, and there's a video on that percent composition, and you can find that in Google Classroom. So question number 10 says, how does that law support atomic theory? Well, it shows the percent of each part, and if you add them all, you should get 100%. So if you have 40 to 60 on one side, it'll equal 100 on the left, and you should get 100% of that on the right side. That's how it supports it. Okay, question number 11 says, when two elements react to form more than one compound, what can we say about the ratio of their composition ratios? Well, we can say that the amount on the left should equal the right, so the amount of the reactants should equal the products, or the amount of the products on the right. Okay, question number 12 says, give an example of two different compounds formed from the same two elements. Well, I go straight to the honeypot, which is hydrogen and oxygen. So you get 2 hydrogen plus 1 oxygen gives you H2O. The other example is a hydrogen peroxide. You get 2 hydrogen plus 2 oxygen gives you H2O2. Basically, you have the same amount of elements on the left as you have on the right. Same thing here, same on the left as you have on the right. Here's my 2 hydrogen, 2 hydrogen, 2 oxygen, 2 oxygen. Number 13 says, how does the law of multiple proportions support atomic theory? Well, the chemical compound always contains exactly the same proportion of elements by mass. Okay, and we'll go into 14. What are the tenets of Dalton's theory? Okay, let me put these up for you. Okay, so here's Dalton's atomic theory. Here's his tenets. First one was all elements are made up of tiny indivisible particles, called atoms. Okay. Number 2 is atoms of the same element are identical. The atoms of one element are different from the atoms of another element. And number 3, atoms of different elements chemically combine to form chemical compounds. And number 4, during chemical reactions, atoms are rearranged. Atoms of one element cannot be changed into atoms of a different element as a result of chemical change. Okay, last question, number 15. Well, not last one, but the next one. Which of the tenets of Dalton's atomic theory have been modified since he proposed it? Well, let's look at that again. Okay, so let's see which ones of these were changed as a result of further experimentation. Well, we found out that, in fact, atoms are not indivisible. There are parts of it that can come off, like electrons. My man J.J. Thomson, he figured that one out, okay? And also, number 2, it says atoms of the same element are identical. The atoms of one element are different from the atoms of another element. Well, that second part is true, but atoms of the same element are not identical because of isotopes. Remember, they have a different mass, right? But they have the same chemical properties because they have the same amount of protons. All right, number 3, that was still pretty good. We haven't disproved that one. Atoms of different elements combine chemically to form chemical compounds. That is good. And then number 4, during chemical reactions, atoms are rearranged. Atoms of one element cannot be changed into atoms of a different element as a result of the chemical change. Well, we just learned about radioactive decay, and carbon-14 can turn into nitrogen-14, but it takes a long time for that to happen, so that one was kind of disproved. Okay, number 16, what is a Crookes tube and how did Thomson use it to show the existence of particles that are smaller than an atom? Well, the significance of that is that's the experiment that proved there is electrons, and let me show you what that looked like. Okay, this is from those slides. They're the Dalton to Thomson slides that are posted in Google Classroom. Basically, what is a Crookes tube is that it's experimented with evacuated tubes that with embedded electrodes charged with a high DC voltage. You got this tube. Positive electrode is called the anode. The negative is called the cathode. And here's what it looks like. Okay, so here's the Crookes tube. You can see there's a charge going through. The electrons are making that light happen there. And then I'm going to fast forward this because he turns off the light. Then you can actually see what it looks like. There is the DC current that you can get, the anode and the cathode with the magnet in it. So that's that. Okay, here's the last one. We'll call this number 17 on this side. And this will be the last one for this video. It's asking you what is an electron compared to hydrogen atom, what is its mass, and what is its charge? Well, electron has no mass, and it has a charge of -1. Compare that to a hydrogen, which has a mass of 1, and if it's neutral, it has no charge because of the 1 proton. Remember, protons have a positive charge, so it neutralizes the negative charge of the electron that's attached to hydrogen. So that's what makes it neutral. Okay, I hope you have enjoyed this portion of the video. I wanted to throw this in there before I finished it, before I forget, some videos to check out if you're still not understanding what I'm telling you. This guy Tyler DeWitt does some pretty good stuff on YouTube. Some videos to check out. There's one called Mole Ratio Problems. There's another one, converting between moles, atoms, and molecules. That's a good one. And converting between grams and moles. Also, there's a guy that does some videos. Just search Bozeman Science in YouTube and check out mole conversions. He does a good job. And of course, I can't forget about the other Mr. C, Mr. Kazi. All of his stuff is cool. So look him up. I should do it like that, yeah. So yeah, look them up and see what you can find. Hopefully some of those will help. Oh, and good luck. Study, ask questions, and kick some butt. All right, guys. Take care and good night. It's too late in the morning. I need to get some sleep. We'll finish the rest of this tomorrow in class. Take care.